All right, let's take a look at the Advent of Code Day 2. This is a file with rock, paper, scissors strategies. The first letter says A, B, or C, and that's theoretically what the opponent is going to play. And the second column, the third character, is X, Y, or Z. And in part 1, it says that's what we're going to play. So X is rock, Y is paper, Z is scissors. And we're going to have a scoring system based on two things. One is the outcome. If you win, lose, or draw, you get 6, nothing, or 3. And another is independent of that. You get points for your choice. So you get 1 for rock, even if you lose, 2 for paper, 3 for scissors. Okay, so first let's open the file. We go with open. That's our contacts manager like I was talking about yesterday. It means we don't have to close the file. We don't have to worry too much about errors. As, and I'm just going to call it data, but we're going to get rid of that name in the next line. Anyway, we're going to call it something else. I'm going to call it strats for strategies. So I'm going to say line.strip. Remember, we had that issue yesterday with the new line characters at the end of each. We're going to strip that off for line in data.readlines. So this is basically a list of what we saw in that file a second ago. Let's print it to show you, or to test if I made any typos. It's going to say, C, Z, whatever. Okay, so that's good. And they're all formatted. We don't have to worry about like, oh, what if there's an extra space, or what if there's a bad character. We can trust it. So what we're going to do is, for strat in strats, we have to score the round. And remember, we have two things. One, I'm going to call shape score, which is like you get 1 for rock, 2 for paper, 3 for scissors, even if you lose. And another is the outcome score, which is win, lose, or draw. Okay, and then we're going to say score plus equals both of those things. I don't have to do it that way. If you wanted to be really clever, you could squish them all into 1 and have like a score from 1 through 9, but I like keeping it separate, especially because, what if part 2 changes it? We don't want to have everything tangled up. So I need to initialize my score as 0, which is going to be the thing we add to at the end of the loop. But these guys we haven't even started yet. So the way it works is that the shape score is easy. We get 1 for rock, we get 2 for paper, etc. And it doesn't matter what the opponent had, so we don't have to care. So I'm just going to use the dictionary. I'm going to say this is for us. Remember, like the first letter is the other guy. The second letter is us, and for us, X is rock, which is 1, and Y is paper, which is 2, and Z is scissors, which is 3. And so I'm just going to go shape scores, and we're going to look that up based on strat -1, which is the last character, which is going to be like this, or whatever. Okay. And then the outcome score, that's going to take a little more work because we have to actually look at ours and the opponent's, because if we put rock and they put something, it changes. If we put rock and they put rock, it's a draw, whatever. Okay, so I'm not going to do that with the dictionary because I don't want to list 9 possibilities. You could, and it would actually save time in one way, but I want to be explicit and I want to leave our options open for part 2. So this is something that happens a lot. Like one thing we're going to do this year in Computer Science 1 is to make a tic-tac-toe game. And when you do a tic-tac-toe game, you could have like a nice, thoughtful algorithm where it goes down, okay, do you win horizontally? Do you win vertically? Do you win diagonally? Or you could say, well, look, there are 8 possibilities. I'm just going to hard code 8 things, look for those, done. And when you have a small amount, you could just pre-compute everything. And with this, it's 9 combos, I think, so we could pre-compute them all. But I want to have it one layer zoomed out and just treat it like who knows how many there could be. So I'm going to go, I'm going to say wins and draws. I don't need to do losses because losses are 0 points and we would just add 0. But wins would be like, okay, and I mean we win, not the opponent. So A is they put rock and we put paper, which is Y. Okay, this is hard. I know. Wins is they put B and we put Z, which is us cutting the paper, and then the other one is C and X, which is us having rock beating scissors. And then for draws we have A, X. I'm sort of rotating them in my mind in a weird way that's hard to explain, but you know what I mean. And then BY, and then the other combo is C, Z, it must be, right? Now, so I'm going to do something very silly, which is like, okay, if we have X and they have A, that's a draw, so that's 3 points. If we have Y and they have B, that's a draw, so that's 3 points. These count for 6. That's just part of the rules. It says right here we get the points for the shape and the points for the outcome. So let's see if we can cram it all into one line, although we could spread it out. I'm going to say 6 if strat in wins, meaning like if the thing that comes up is one of these, we get 6. Else 3 if strat in draws, else 0. I know that's kind of goofy. I could spread it out through a couple lines.
At this time, anyone in an English class, if you need your picture taken, please go to the Marshall Center. Anyone in their English class that needs their photo taken, please make your way to the Marshall Center.
So we have picture retake. That doesn't affect us because this isn't English class, but if it was, you would go to make up the retake, or make up the picture day. So this, I think it's got it. Let's say print score, and if I run this, it's going to say, okay, we get the shape score, which is based on simple, and then we get the other score, 13,682. Is that right? Let's see. I typed it in earlier. It was, in fact, 13,682. So that's how we get the first part, which is they tell us what the opponent has, and they tell us what we have, and we just have to calculate the score. That's nice and easy, although it required a bit of setup. And the second part is where it gets interesting. The second part says, you know what? We were wrong about what the columns meant. We were correct that the first one is your opponent's choice, but the second one is what we're supposed to do. Because remember, if you're cheating, if you have the opponent's strat ahead of time, you want to have like a mix. You don't want to win every time, so they would figure it out. So X means we're supposed to lose, Y is we're supposed to draw, and Z is we're supposed to win. Okay, so this is kind of the opposite of part one. In part one, we had the shape score easy because you could just look it up independent of what the other guy had, and the outcome score we had to figure a comparison. But in part two, it's the other way around. Outcome score is easy because it tells us what we need to get for the outcome, and then shape score is hard because we have to figure out what shape we're using in order to get that outcome, which means we have to look at the opponent's thing, blah, blah, blah. You get the idea. Okay, so I'm going to say, let's just comment that out and write a new one based on part two, because I think we might have to change some stuff. In this case, I'm going to do outcome score first because it's the easy one, and it's just going to be based on the third character. So we have X means we lose, Y is we draw, and Z is we win. Okay, so I'm going to change, or I was just going to make a new dictionary. Kind of like yesterday we were making new lists all over the place. This time I'm going to make new dictionaries all over the place, or at least I think I am. Outcome scores, we have X I'm just going to copy this. What the heck? X, we need to get 0 points. Okay, we don't know how. Y, we need to get 3 points. We don't know how. And Z, we need to get 6 points. We don't know how. So that is kind of what we're doing here. Outcome scores with the last letter. So the last letter says X, we need to lose. No matter what they have, we got to figure out how to lose. Y, we need to draw. No matter what they have, we need to figure out how to draw. And Z, we need to win. No matter what they have, we need to figure out how to win. So how can we do that? Probably not like this, right? It's going to be something else. It's probably going to be a 2-step process. We're going to need to figure out what they have, what we need to achieve, and then put those two things together. Maybe we could skip a step and sort of roll them into one, but in my mind, this is looking like a function because we've got sort of 2 inputs. We've got like the parameter of what the other guy has and the parameter of what we're gonna look for. So I would think that feels like a function with 2 parameters. I don't know. I'm sure there's a faster way, but this is nice and explicit, and everything's labeled, and we're going through step by step logically. So I don't know. We could use these. Let's see what happens. Let's just make a little function. I'm going to call it fix game because it's like we're shady gamblers who are fixing the game by achieving a certain outcome, which means sometimes we'll intentionally lose, etc. So we're going to fix it based on the opponent and the outcome. Opponent choice or something like that. Okay, so we could run the character through this dictionary and use the outcome score, or we could just use the outcome code directly. You know what I mean? Like, I can just say, if outcome code is X, then we need to lose. Figure out how to do that. If outcome code is Y, we need to draw. And if outcome code is Z, we need to win. Okay, so how do we achieve that? Well, we can probably look it up in a dictionary. So how can we do that? To lose, we need to pick certain things. I could probably repurpose these. I'm just going to make a new thing. And I might just make a dictionary right here and use it in place, which is kind of silly, but let's see what happens. To lose. Okay, how do we lose? Would somebody get the door, please? How do we lose? We can say, if they do A, which is rock, we need to do paper. Or no, we need to do scissors to lose. So this is going to be hard mentally to adjust all of these. If they do paper, we need to do rock, which is X. If they do scissors, we need to do paper, which is Y. Okay. We need to return this thing based on opponent choice, and I'm going to use that modified in the other guys. Okay, so if we're trying to draw, that's the easiest one because it's AX, BY, CZ. It's just lined up, stacked on top of each other. And then if we're trying to win, we have to do the opposite. So if they do rock, we need to do paper, which is the second one. If they do paper, we need to do scissors, which is the third one. And if they do scissors, we need to do whatever, Z, or X, we need to do rock. Okay, so shape score equals fixed game with strat 0 and our strat -1, because we're just sending the code, we're not sending the number that we're aiming for. And then what do we do with fixed game? Well, that's returning what we need to get. So we need to go shape score of that thing. Let's try that. I think I stacked up a lot in one line, but I think it's gonna work. Let's see. Remember that one line. Oh, shape scores. Okay, so that's taking what we see as the opponent, taking what we need to achieve, sending them off to this function which figures it out, and then uses that to get our shape score for this. Again, I'm certain you could simplify this by just pre-computing everything by saying, like, well, if it says AZ, then we need to give them 9 points or whatever. But I kind of like the idea of going through it step by step, labeling it all. Who knows? Let's see, was that the right answer? Yes, I typed that with my earlier class, although I probably wrote it in a different way. So that's good. Let's go with that for day 2.